Okay, so we're going to look at a very specific case of forces, and that is when you have an object on an incline. And when you have an object on an incline, you have to be particular about how you break up the forces. So when you have an object on an incline, you are going to rotate the coordinate system to minimize the amount of forces that have to be broken up. So the way we're going to rotate our coordinate system is we are going to rotate the system such that the x-axis is along the incline. Okay, so rotate the coordinate system such that the x-axis, which is typically the direction of motion, is along the incline. So let's get a visual on this. So let's say you have an incline, and typically our coordinate system is like this, right? Where here's our x direction, here's our y direction. But if you have an object on an incline, let's think about the forces. So here's like a box, generic box. Let's draw the forces acting on this. So we always start with our weight vector. So here's our Fg, goes straight down. We have Fn. Fn is the normal force from the surface. It has to be perpendicular to the surface, so there it is, perpendicular. And then we have Ff. Let's say if it's moving this way. Ff will be going up the incline because the force of friction is opposed to the motion. So in my traditional coordinate system, the only force that is actually along one of the axes is the gravitational force. I would have to break up Ff into an x component and a y component, and Fn into an x component and a y component, and that is just tricky. So I want you to get into this habit of, when it's on an incline, take our coordinate system and rotate it such that x is along the incline, so it's kind of angled, and that's going to force y to be rotated as well. If we rotate our coordinate system, you can see, Fn is now along the y direction, and Ff is along the x direction. It's the negative x direction, but it's the x direction. And so realistically, if this is my coordinate system, the only force I have to break up is this Fg. And Fg would be broken up. Part of Fg needs to be on the y-axis, and part of that Fg is along the x-axis. So you kind of see, part of Fg is going to oppose Fn, and we'll call that Fgy. And part of Fg is going to be along the axis. This is the actual component of gravity that is causing this thing to slide down the incline. Okay? You don't have the full force of gravity causing it to slide down the incline, just a portion. So let's kind of look at how do we break this up? Like, how mathematically can you break this up? Because in order to break a vector up, you need to know its magnitude. Well, Fg, that's easy, right? Fg is just mg. I know the magnitude, but I need to know an angle, okay? Typically, in a force problem, when you are told an incline, you're told what the angle of the incline is. So you know this theta value, this angle value. So let's kind of look at the geometry of the situation and figure out how can this angle value apply to this triangle here. So I'm going to zoom in and just focus on this triangle right here. So I still need to kind of have this visual of my incline. Okay? So here's my theta value. Again, I'm just going to focus on Fg. So here's my Fg. My Fg comes straight down. And my Fgy, my Fgx. Okay, so like this is my hypotenuse, and these are the legs of my triangle. Okay? So look at this. And I'm just going to put a number in here for now. So I'm just my favorite angle is 30. I don't know if it really is or not, but let's say this is 30. Okay? Fg comes straight down. And if it comes straight down, it means that this is 90 degrees. If this is 90 degrees, it means this triangle triangle here is a right triangle. So if this is 30, this has to be the complementary angle of 60. Well, FGY is perpendicular to the surface. It has to be. It's along the y-axis here. It has to be perpendicular. So what that means is that this is 90 degrees. So if this is 60 and this whole thing is 90, it means this piece has to be 30. Okay? So what this tells you is that this angle here that you're going to use to break up your FG is always going to be the same as the angle of the incline. So right here, this right here, that's 30 degrees. And that's going to allow you to figure out what FGX and FGY are. And if we think about just the SOHCAHTOA stuff, FGY is adjacent to the angle. So when I'm thinking about my equations here, I would say, well, cosine of 30 is FGY over FG. And I'm just going to put MG here. This means that FGY is actually equal to MG cosine of 30. And now if I did the same for FGX, FGX is opposite that angle. So sine of 30 is going to equal FGX over my FG, this piece here, which is just MG. So FGX is equal to MG cosine, MG sine of 30. And we're going to see this relationship a lot with objects on an incline. Okay. So let's look at an example of this. You have this in your workbook here. Got a little blurry here. A block whose mass is 2 kilograms slides down a ramp that has a 50-degree incline. The coefficient, oh, it's got all messy up. The coefficient of friction is 0.597. What is the normal force? What is friction? What is the acceleration of the block? So just like all force problems, the first thing we're going to do is we're going to draw a force diagram. Draw the free body diagram of this thing. So just to mix it up, I'm going to draw my incline the other way, just so you get experience. Here's my block. It's sliding down. Let's draw our forces. So start with weight. Weight goes straight down. We'd have to break it up into a y component and an x component. We have normal force perpendicular to the surface, and if it's moving down, that means friction is along the incline, and we definitely have an acceleration. So this is my force diagram, and now I'm going to take this and I'm going to use my equations to kind of figure out how do these forces combine. Okay. Let me do a little bit of erasing here. So let's start out with our Fx, horizontal forces, okay? And again, remember, we've tilted our axis. Our coordinate system, here's my y, here's my x. So that's my coordinate system, my x direction. So in the x direction, I have Fgx going down and Ff going up. But remember, direction of motion is always going to be positive. Direction of motion is always going to be positive, which means Fgx is positive and friction is negative, and that's going to equal max. Okay? And I definitely have an acceleration in the x direction, so I'm going to leave that there. Let's do the y equation. So vertically, now vertically my y direction is like this. So vertically I have Fn, and then I have this FGY. Fn is going up, FGY is going down, so I'm going to subtract them. So Fn minus FGY equals MAY. Now here is where we kind of think about this. We have rotated our coordinate system. So the y direction is like this. Your object is not accelerating that direction. Like it's moving down the ramp, but we've now defined x is down the ramp. Y direction will be like it's jumping off of the incline. It's not doing that. So this is actually 0, which then just says, oh, well, Fn is just equal to Fgy. That kind of simplifies. Okay? So we've written out our equations. Now let's actually look at what the problem is asking you to figure out. So we're told the mass, we're told the degrees, we're told the coefficient of friction. The first thing says, what is the normal force? Right here. Normal force. Fn is equal to Fgy. And remember, Fgy is going to be mg cosine of theta. So that's going to be Fn equals my mass of 2 times 9.8 cosine of 50. You should stop the video. You should actually get your calculator out and figure out what this is. Fn should come out to be 12.6 newtons. Okay, next part of the question says, what is friction? All right, here's friction. So let's plug in what I know. Fgx is mg sine of theta minus friction is equal to max. Okay, here's where I've got a little bit of roadblock. I have this. I know my mass and gravity and theta. I'm looking for this. I don't have acceleration. So I can't use this to find my friction. But I do have this right here. That's my mu value. That's my coefficient. So I have mu is equal to 0.597. There is another equation of friction. Okay? I can find what friction is by saying friction is equal to mu times the normal force. This is the general equation for friction. So this would be 0.597 times my normal force of 12.6. Again, you should pause the video. You should calculate this out. And get an FF value of 7.52 newtons. Okay, and then the last part says, what's the acceleration? Okay, I have this friction. I plug this in here, and I can find this. So let's plug in some values. My mass here is 2 times 9.8 sine of 50 minus 7.52 equals 2 times acceleration in the x direction. Okay, you should be able to solve this. Okay, I'm not going to give you the value. We'll come back to class and you're going to tell me, and we'll see if we agree on what that value is. Okay. So again, key idea with things on an incline is that you have to rotate your coordinate system such that you break up FG into an FGX and an FGY. Okay?